uh, as the title talked about, we're all about continuous quality, and today we're going to talk about what we need to do to really establish a continuous quality practice and overcome some of the hurdles that many organizations face. And really, this is where we want to hear some of your challenges as well. So firstly, it's important to kind of note that quality is an important topic for today's organizations, and really it is highlighted that it is an executive level issue, or an executive level visibility within organizations. So you can see here Walmart, United Healthcare, CVS Health, all talking about how quality is critical for them to deliver the innovations to market that are going to help them succeed, both in their current markets as well as establish new markets. And these quotes all came directly from either annual reports or investor conferences. So it's top of mind within the senior levels of the organization. It's also a key driver for development teams and the business as a whole. In preparation for today's session, I also was kind of researching different metrics that organizations use as they relate to quality, and was actually a little surprised, to be frank, that I saw that quality was in the top 2 metrics that development teams use to track their success. I was actually expecting feature user story completion to be the number 1. That was actually number 3. But increased test coverage, increased defect remediation, reducing defects in production, which is a critical metric to monitor to know that your continuous quality practice is working correctly, and reduced time to mediation. These are all metrics which development teams are surveyed as being their top 2 priorities. Also looking at business leaders, we see that quality is a strategic business requirement, with many organizations considering quality improvement, or better speed and quality, as being the top priorities that drive those organizations. So again, go ahead and let's be interactive. If what quality drivers are driving your organization? Are you seeing something different? Do you see quality as an imperative for some other reasons within your organization, or does this kind of represent what you see in your teams? So I am going to be trying to monitor the feed as we go here as well. So I will be looking back and forth. So please, again, we'd love to make this interactive. It's a little difficult being virtual, but don't be shy because you're not on camera. I am. Okay, so let's kind of step forward a little and think about what the challenges are when it comes to software quality, specifically the cost and how we can reduce the cost of quality, security, and compliance, which really are the 3 drivers for organizations to quantify successful delivery of software projects. Quality is a critical component when it impacts my business. So when it impacts my business from a security perspective, from a compliance perspective, or potentially from a system outage. So what are the 3 things that we can do to help reduce the cost of quality? The first is test earlier. Shift left is overused in the industry. I think you've probably heard it half a dozen times today already. But really, when we're talking about shift left, it's saying, okay, what are we trying to achieve? We're trying to complete testing in sprint. And the reason why we want to do that is this is where it's quicker, cheaper, and easier to remediate any problems that are identified. Also, if you are leaving testing until the next sprint or towards the end of the cycle, you're basically building in technical debt into your software development process that has to be addressed. And that's going to really have a problem for you at crunch time. Next, test faster. We want to automate the testing. That's a kind of a given in today's world. Trying to, we can't manually test in today's agile DevOps world. We can't keep up. So we want to automate where possible, and we actually want to execute them continuously. What you want to do is you want to be able to not just execute them kind of when I'm saying that at the end of the sprint, I'm going to go ahead and execute, or the end of the release cycle. I want to create my tests in sprint and then execute them continuously moving forward, meaning that I've got a growing regression suite during development to capture the problems immediately when defects are introduced. And then the third is I want to test smarter. Or sometimes I might say, I want to test less. I want to not try and test everything and do everything in a sprint. I want to focus on the things which I'm working on today, because that's where the risk is. I want to focus and to create, spend less time creating, less time maintaining, and less time executing the test scenarios. As we increase our automated regression suite, and especially as we increase our testing of UI-centric testing practices, what we're going to find is those execution times take longer and the cost of the infrastructure starts becoming a challenge. What we want to do is actually optimize where I'm working from a creation perspective, optimize my best practices for maintaining, so leveraging techniques to help me reduce that, but also reduce and focus down the test suite that I'm actually executing during my in-sprint cycle and going from sprint to sprint as well. So what are the 3 challenges that we see many organizations face when they're typically struggling with going from an automated testing practice to a testing practice that's running continuously? So they really come down to 3 areas. And again, please go ahead and chime in. Tell me which one's the most important for you guys. This is where we can be interactive and change the presentation on the fly. But if not, I'll go down this path. Number 1 is expertise. Teams are being asked to do more. They're being asked to learn more, adopt new practices, adopt automation, adopt API testing. And that can become challenging when you're trying to adopt those new practices, but also as you're trying to enable a team as a whole. The second would be the execution of the automation. And automated tests get a little bit of a bad rep for different reasons, but one of them is actually the instability and reliability of the test suites. If you're spending all your time fixing broken tests, you can't really spend the time finding the problems because you're having to maintain and manage the test suite. So that's obviously a big area. And then third is the test environment as a whole. I might have an environment that's available to me towards the end of the development iteration or during scheduled hours when I have access to maybe the back-end mainframe or third-party systems. That environment becomes a key constraint or bottleneck to being able to run your tests continuously. So, you know, other than Austin barbecue, sending some barbecue from Austin, which, by the way, Austin does have fantastic barbecue restaurants. Let's talk about how we can actually translate the expertise of the team or kind of evolve the team so that we can reduce some of the problems and burdens associated with adopting new practices. Typically, when I talk to organizations about the challenges that they have of scaling a test automation practice associated with the team members themselves, I can say that they fall into 3 different areas: UI test automation, API testing, and then when we're starting to look at trying to shift left my practices further, the concept of performance testing and how I can kind of get a jump start on identifying performance issues earlier in the process. This is really some of the 3 key practices that I see organizations struggle with. UI test automation, Selenium is the de facto standard in the industry. So, you know, here what we're going to be wanting to look for is technologies that can help me create test cases or create frameworks that I can very quickly extend, reducing the skills or the complexity associated with test creation. Now, there is the concept of record and playback, you know, a lot of people have used that historically, and again, it's another thing that kind of gets a bad rep. And if you're leveraging a record and playback capability, what you want to do is to identify something that's actually going to create you tests that are in a reusable and maintainable format. This is where the page object model is actually a very powerful framework for creating test automation. Rather than isolated test scripts, leveraging a modeling of your website and the objects within it means that it's easier to maintain, it's easier to understand, and it's also easier to reuse those underlying test frameworks. API testing is really the sweet spot when it comes to the test automation pyramid, which many of you are probably familiar with. the ability to very easily optimize UI test automation workflows through API testing is actually a key element to helping you accelerate your continuous testing practice. So how can I take a recording of an interaction with an application and then build a model of that I can use to do a very efficient API level interaction? And this is, APIs are powering 90% of the modern applications out there. But the challenge is when I publish an API using an Open API document or a Swagger document, I don't necessarily know how it's used in a connected workflow. I understand what an individual operation is. I might have some example payloads, but I don't really have an example use case. And what we want to do is to be able to create a real world API test scenario by modeling those interactions. And then third is, as I mentioned earlier, performance testing. As we as an industry look to shift left our practices, well, the whole point of shift left is to find the problem sooner. And if you think about traditional approaches to performance testing, here what you're looking at is you're looking at performance testing at the end of your release cycle. So I've done a whole bunch of development sprints, I've added a whole bunch of functionality, and then I get to the end, and now we pass it over to the performance team, and lo and behold, they find a problem. Trouble is, your development team have moved way past then. Couldn't I have caught it sooner? So this is where you want to be able to start leveraging your capabilities or the test assets and artifacts that you're creating as part of your in-sprint testing process, and figuring out how you can use them to scale load efficiently and get an early stage warning from the point of view of potential performance issues. So let's actually talk a little bit about how we at Parasoft can help. And I'm actually going to see, I'm looking at the chat. I'm also might be able to weave in a couple of demos as we go through this as well today. My colleague from Joy is Joy Ruff from Parasoft is also on the chat there too, so she can kind of steer you and answer some of those questions as well as we go. Okay, so how can we help with simplifying test automation with Parasoft technologies? Parasoft has a Parasoft Selenium for UI test automation, leveraging the Selenium framework, and Parasoft SOAtest for doing API test automation. Parasoft Selenium is unique in the industry. What it does is it records your interactions through a Chrome browser plugin, and then will create you pure Java-based Selenium scripts. They can be created within an Eclipse or an IntelliJ IDE. They're leveraging the page object model that I mentioned before, and they're doing it without any vendor lock. So those tests that are created are pure, what I like to think of as pure Selenium tests. As I add additional use cases or do additional recordings, I'm actually adding to the page object model. I'm not creating a completely isolated test scripts. They're leveraging that core, those core page objects. I can also leverage that same UI interaction through the web browser, or actually leverage your existing Selenium tests and parse that through Parasoft's AI engine in Parasoft SOAtest. What this does is gives me the ability to analyze how the underlying APIs are used and chain those together into a test scenario. So it's not just a series of isolated recall and playback APIs. We're looking for relationships between those APIs and connecting them together into a scenario. That scenario then obviously goes into my testing repository, where I start adding human intelligence to those API tests, which might include additional authentication authorization processes. It might include assertions associated with particular types of payloads. That information can be extracted from your test repository and used to train the brain inside of the API testing engine, so that we can create more intelligent second and subsequent test scenarios. So let's actually see those two in action. I think we have time to be able to throw in a couple of demos today. So first of all, here we have a website, a web application. It's a very simple kind of banking example. I think you guys can see that okay. And I'm actually going to go ahead and just jump straight in and start recording. So here I have my plugin in Chrome. This isn't a Salesforce or a Guidewire application, so I'm just going to use the general recording type and say, okay, start recording. Okay, and then I'm going to just do exactly that interaction. If my mouse will behave. John demo. Oh, I gave everybody the password. This is actually a public site. It's actually used in our trainings. I know Angie Jones actually uses this in some of her classes as well. So here I've got an application, a website. I've logged in. I can see my funds. I can go down and say, okay, here's the detail from my bank. Maybe I'm going to click on this first check, and then I say, okay, here's the transaction details. Maybe I also want to create an assertion. So let's actually create an assertion to say, oh, you know what, the let's say the transaction ID should be 1245. And then let's create another text assertion. Let's say the amount should be 300. Okay. So just a couple of simple examples there. I'm going to go ahead now and log out the end of my test case and go ahead and say stop recording. Okay, so let's give it an example, a name. Let's call it SOAtest session. You know, I could give it a description. This is the demo of Selenic. I could also at this point actually associate this particular work item, or sorry, this particular test with the work item. So for example, a requirement in Jira, I might say, okay, it's you know, a particular work item ID. I could even put a URL in here if I wanted to. Okay, so now I'm going to download the recording of my my UI test. I'm going to put it into my example folder. And then it moves me to the next step, and it says, okay, now I want to create API tests leveraging Parasoft SOAtest, the same work item association, the same test name. And now I'm going to say create test asset. This is going to actually talk to my SOAtest desktop, and it's going to create the asset on that instance. So I'm actually going to click create asset, and then in a moment I should get a dialog here. Hopefully you guys see that. Yes, you do. Okay. Oh, and there's my antivirus kicking in. Okay, so we've got, we should have a test for us to go ahead and look at in a moment. So let's go ahead and get rid of the web UI. Let's do this. Let's go ahead and look at the Selenium test first, seeing as that's often the place where most people start. They start kind of like, how do I automate my web UI? This is just an Eclipse IDE. So you may not be familiar with Eclipse. You might not be familiar with Java code. Don't worry. Once you've actually got the IDE installed into the IDE, is actually, sorry, the plugin installed into the IDE, is actually very straightforward to get started. So here I can go ahead and say, create a new Selenium Java project from recording. And I'm going to call this SOAtest 2021. I'm going to go ahead and get my UI recording that I just did a few moments ago. Here it is, SOAtest session. Okay, and I'm going to go com.SOAtest, and I'm going to call this a simple example test. Okay, and when I do that, it's paused that recording and it's captured, as you can see here, that scenario that I just did. I logged in, I clicked on the bank overview, I clicked on an activity, and I did a couple of assertions. So yes, this is Java code, but it's not, you're not trying to build an end-to-end Java application. What you're doing here is you're simply using Java as a scripting language, and you're doing it in an intelligent way. So I have my page objects here, which represent the different objects on the web page. And then I have the elements that I can interact with. I could also, as I said before, start adding additional tests that I recorded during multiple sessions. So I can go ahead and say, let's add another recording. Let's add one, just this update profile one. And it's, again, I'm loading it into the class that I just created. It's got its own name in it because it was from a previous recording that I did. And then I click finish. You might have noticed there that the page objects were updating, and you'll notice that I have a new test case that's appeared in my view here. You could also see when I did that recording, it was actually back in May versus the one that I did today, which was in April. So actually May 2020, so actually almost a year ago that I did that one. Okay, so I created the tests. Now I just say, okay, but I still need to run them. So let's go ahead and do that. Let's actually run those two test scenarios, and I'm not having to get into the guts of how to, figure out Selenium, how to figure out the different pieces of code. I'm basically just done a simple record and playback. You can see it's running easily there. And you can see that I've got my assertions worked. Actually, I should have broken an assertion so you could have seen a failure. But you can see that it's going through and reconfiguring the system. Okay, so it's a starting point, and it's code. So you can change it and modify it as you need to. Now, let's go ahead and switch to talking about API testing. In this particular example, API testing is typically a little challenging for most people because you know what APIs are there, but you don't know how they're being used. So as we were interacting with that web UI, there were a number of underlying APIs that were being called. And here I have the test scenario that was built from that. Okay, so let's go ahead and actually expand all of this. Oh, UI just went a bit weird. There we go. I can see I've got a series of API steps, and then you'll see some things called like smart data banks and smart diff controls. These are things that were injected into the test based upon the observations as we were doing the execution. So here, I've got an API call that's going and getting the accounts for a particular customer, and then we're extracting an element. That element is actually going to be used in a subsequent test. So here, this one is actually saying, get me the specific details for this particular account number, and it was returned from that first list. So you can see here, test 3 ID, test 3, and the data bank is called ID. So it's automatically determined that it needs to extract out that particular value. Also, because I'd already trained my brain a little bit, so to speak, we actually had, it also has an assertion in here, which it added automatically because of the training that I did prior. And it's saying that every element of the bank's balance should be, get my UI to work a little bit better, greater than 0. So if I go ahead and run this, I'm probably going to get a couple of failures because session tokens are going to be changing, but we can suppress those in a second. So here, and okay, yeah, so I have a session token that's not working correctly, which is probably to be expected. So let's go ahead and look at my failures. And then I've got, here's my particular one. So this is the interesting one from the assertion. So you can see that there's actually some bank accounts that have a negative balance. It's actually what we saw on the website and would be expected. I also have a couple of tokens that have actually been, have changed because of the session. These are actually very, it's a very common situation. What it's doing is it's actually doing a diff on that. So we could go ahead and say, actually, let's go ahead and actually ignore those and say, don't validate token details. So we can go ahead and actually ignore those as appropriate. But what I've got is I've got a test scenario here that's running through each of those different things. You can see here that we've got the data associated with a particular value. It's typical bank accounts that we were accessing as part of our sequence. So what we did is we very quickly went from a manual interaction with my UI and converted that into a UI test scenario, so using the page object model, but then also converted it into an API test scenario through the use of the machine learning engine. As I said before, anything that you do manually to those tests, you can use to train the engine and train the brain, and that's where that assertion came from. That is, there's no way to know by just looking at the payloads that a particular value needs to be asserted on, but I can add that information into my repository and then extract that out to drive the second and subsequent trainings in the future. Okay, so let's move down and start talking about, okay, once we've got going, the next problem is going to be around the execution of the tests and really targeting two primary things, stability and execution time. So let's talk about those challenges. And in the same way as we see these challenges appear within other organizations, please go ahead and put some things into the chat which I've now lost. Okay, so put those into the chat, and then we'll see if we can kind of inject some of those pieces into the conversation today. Okay, so changing the UIs, and I actually see that as one of the challenges here that's being commented on, is like a mix of products and changing the applications. Yeah, time spent maintaining tests due to automation that fails. This is probably the #1 challenge that I see organizations face when they are actually trying to adopt test automation at scale. It erodes the value proposition for test automation if you're spending all the time fixing your regression suites. It means that management don't trust the data that they're looking at if every time they look in a dashboard, all they see is a bunch of red crosses, no green check boxes. So it really kind of undermines the value of test automation. So what we want to be able to do is we want to be able to detect and adapt, and be able to give us the ability to not only understand why a test failure has occurred, but potentially identify how we could refactor a test case very quickly, but also perform something referred to as self-healing. So self-healing is something that many people talk about from a UI testing perspective, and we'll touch upon that in a moment. The next is, when you see test failures, you want to understand the impact of the test failures on the quality of your application. So, not every business requirement is created equally. Some are more important than others. But if you've got a testing suite that is kind of in complete isolation and not correlated back to your business requirements, you don't understand, first of all, if the core business requirements have actually been tested in the first place. You also don't understand that when you get a failure, is that associated with that business impact? And so traceability back to those core requirements is critical for you to be successful, and critical for you to be able to proceed moving forward. And then the third area within this workflow is talking about optimizing the execution time. So optimizing what you're executing. You might have a test suite that will run overnight, and you'll be like, yeah, I'll just wait until the next day and I'll get my results. Okay, you might not be that lucky. You might have a test suite that's so big you actually require a weekend or potentially in some cases longer, the time to run all of those tests to get the feedback for the team. The thing is, though, in today's world where development are moving forward at such a rapid pace, you can't really wait that long. You want to get the feedback as quickly as possible. So this is where you want to start leveraging concept of smart test execution, so we can actually correlate our tests with the underlying code as well as the requirements, and then only execute those tests that you need for in-sprint feedback. Use those during the course of the day, get very quick feedback to the development teams, and then still run your full regression suite at the appropriate times. But what you're trying to do is optimize that feedback cycle. So let's go ahead and actually look a little bit at that. Let's actually tackle the first one. Let's talk about the self-healing concept and the idea of around how we can fix our builds as we go. So we're going to leverage our same Selenium test process. Now, this time, though, when we run our tests, we're going to run our tests against a new version of the application. And there'll be two use cases where the UI has changed. One of those use cases, a new element's been injected, and now my element locator strategy doesn't work. And the second test case, we're going to see that there's a new UI element that's been introduced that slows down the execution of the sequence. So I now need to worry about wait conditions. When we run these, you're going to see that actually Selenium is going to fix those problems for me. It's going to self-heal the test at runtime, but it's not going to actually change the test. It's going to just change how it's running at runtime. What it's going to do is it's going to give me feedback back into the IDE. So me as a tester, I can actually take that and say, okay, yes, it looks like that was the right thing to do. And then through the use of quick fix technology in the IDE, I'm going to update those test scripts. It's kind of like a human in the loop process. We also can, as part of the execution model, take that same execution and send that data to centralized reporting and analytics dashboard, which is where we're going to start doing correlation with our backend ecosystem, which I'll probably step to as well if we have time. Okay, so let's go ahead and just see what we can do here. Okay, sorry, my user interface has just gone a little bit. I want to get that one away. I want to bring back Selenic. So here what we have is I'm back in Selenic. I'm back, or should I say I'm back inside of my IDE. I've actually got a pre-configured example that I'm going to run right now super quick. And I'm going to run against a new version of that same website that we were running against earlier. So when I do that, let's make sure I've got the right screen set up. Here we go. When I do that, I'm going to point out the two test cases that are having challenges. So here we're going to run, it's going to be a slightly bigger test suite than we had before in our previous example. It's the same kind of thing. So I'm going to log in. Okay, that was just a simple validation of login. Now it's going to do something called test account overview, which probably goes in and looks at the test accounts. Yeah, okay. That one looked like it passed. And then I've got one that's just going to go ahead and look at some of the administration function on the application. You see it's flying through those UI elements. Looks like it's pausing here, which probably means there's going to be an assertion failure on the test. Okay. All right. That's taking a little longer than I was expecting. Oh, no, there we go. Okay, yep, the test did fail. I then have a request load. Now this one should have a piece of UI that's waiting to refresh. So you see the from account element, it's saying loading ... That's the type of thing that would typically break a test automation because the element isn't there. So what happened there was Selenic actually self-healed that test. And here's another one where we're going to see it's going to go in and it's going to struggle because it can't find the right field. It was a phone number element that was added into the UI, which messed up the element locators. So it was searching, there we go, found a new one. And then here's my test suite ran successfully. And we're going to see in a second, we're just running the analyzer. We should see an HTML report pop up. And in that, we're going to see the results of the test automation. Okay, here we go. So we were running with a few different options turned on in this scenario. So here you can see I've got 5 tests that were available to me. One of them passed, just worked. 2 actually were healed, meaning that there was a problem, but we actually fixed that problem. You can see here, one is a healed locator, the other one is a healed weight condition. I then can see that 2 tests failed, just outright failed, either for a bad locator or weight condition or other failure option. You can also see the details of that here. We can see screenshots where we can get access to. The thing that I want to focus on super quick is the element locator one. So here, if I look at the details of that element locator, we can see that the AI, the machine learning engine with inside of Parasoft Selenic analyzed the historic data associated with the runs against the web application and came up with a determination of what the best selector framework would be, or the selection approach would be. And you can see I've got confidence factors associated with each of these different element locators. We can also see the details of the stack trace. I can also see a screenshot of the where it got stuck when it was doing the execution. So let's go ahead and actually return to the IDE though. And if I look in the IDE, I've now got a recommendation, that same information that was there on the page, which said, okay, there's an element that's broken and I healed it. This is the test that was being run. There's bank bill pay. And here's the element locator that needs to be changed. And here I can go ahead and come in and say, yep, this is the element locator that I think I should use, or I could select a different one. And then I can go ahead and actually update the code. Actually, just pick a different one for giggles. So here I can go ahead and pick the CSS one and actually say, okay, now it's updated that element locator for me inside of the page object model. So any other test which is leveraging this page object model is going to get that same update to the underlying test framework. Now, I do want to show you one other thing as well, which is if we, oh, let's see, that screen's just gone away. So just let me bring that back. One of the things that I was mentioning was about how we need traceability to make sure that we understand the impact of any test failures. So what I'm going to do now, if that'll come back up, there we go, is I'm actually going to show what that looks like inside of the reporting dashboard. Yeah, here we go. Okay, so if I log into my reporting dashboard, here's where we can aggregate data from across the your quality practices. And sorry, my antivirus is going crazy right now, so I'm going to have to turn off a couple of things. There we go. Okay, so here I've got a centralizing reporting and analytics dashboard that's bringing to data from across my software quality practices and correlating all of those different things together. So one of the things that I can do, for example, is to start to bring in the test results and correlating them with the core requirements from my agile management system. So in this case, Jira. So here I can see that I've got actually 98% test coverage. So 44 out of 45 of my user stories have been exercised. And then I can also see kind of what the level of test coverage and association of failures are. So I can see here I've got 10 stories that actually have failing tests. And I can drill down further and actually start to see the details of that. So I can see the specific user stories. I can actually drill down to the details of specific tests that are failing, understanding what the relevance and the importance of those are. And then I can even further drill down into the specifics of a particular transaction and see, for example, the details associated with a particular issue. So this is that there's some data problems associated with a particular test case. And I can say, okay, yep, let's create a Jira ticket, or let's go ahead and assign it to somebody as appropriate. Having that traceability gives me the ability to not really determine, the total testing, but it gives me the ability to understand what the impact of my testing is against those individual business requirements. We can also start to correlate that data with the underlying code that's being exercised as part of my functional testing practice as well. So here, even though I've got 98% test coverage, meaning that I've got 98% of my user stories that have been exercised with tests, the underlying code is only being exercised less than actually 20%, which is probably a concern for me. It tells me that I've probably got a whole bunch of code in there which doesn't have value potentially, or maybe my tests that are doing the work are not actually testing thoroughly. This gives me the ability to get an insight as to how well I'm testing and how completely I'm testing. Okay, so let's go ahead and switch back. So we talked about how we talked about the traceability. We talked about how we can correlate the results of my test automation back to the original system of record. We touched upon code coverage and test coverage in that conversation. But what I also said was what we needed to do from an execution perspective was optimize what it is that I'm executing so that I don't have to execute thousands of tests during every check-in that's going on during the day. This is where we leverage something referred to as smart test execution. And here what we're going to do is we're going to say, look, we've got two different types of approaches that we're going to take for smart test execution. And what they fundamentally do is they correlate the three artifacts associated with my testing process: the tests themselves, the user stories that they're validating, and the underlying code. So we have two approaches to smart test execution. The first being work item-based execution. So here I can say, during this sprint, I am going to be exercising, or I'm going to be working on these user stories, which means I need to execute these particular tests associated with my development process. And I'm going to say, look, I'm going to execute those during every check-in because I'm going to want to be able to make sure that the work that the development team are working on, I've got a practice of validating that as it's being implemented. This is also a way of trying to focus a TDD driven practice where you have the tests are correlated with the user stories, but I don't want to execute all my tests. I just want to execute those ones the development team are working on to implement. The second side, though, this doesn't really take into account how those tests are actually exercising the underlying piece of the code. So with Parasoft technology, leveraging that same coverage information that I showed you earlier, we're able to understand when some code changes, what tests are actually exercising that code. In this particular illustration, we've identified 2 additional tests that need to be executed as part of the process to validate the completeness of the changes that have been made. These 2 techniques together give you the ability to really optimize and hone in your testing strategy so that you can get immediate feedback as part of that CI/CD process, really on every developer check-in. Okay, so we talked about expertise. We talked about how we can quickly create tests, how we can kind of lower the barrier of figuring out how to do Selenium, how to do API testing. We talked about shift left performance testing and how we could reuse those artifacts. Unfortunately, we don't have time to demonstrate that today. If you'd like to find out more, please come by, visit the booth. We talked about execution. We talked about addressing instability and reliability through self-healing. We talked about smart test execution for time management. We also talked about traceability. That leaves the last thing, which is the test environment itself. And really, the test environment is possibly one of the biggest problems for an organization to face because there's so much that's outside of the control of your particular group. So typically, I kind of think of these things in 3 ways. They're either unavailable, meaning it's a third-party system that I'm waiting to have access to. It might be a mainframe that's an internal system, but we have to schedule the time when we're all using it because we don't have data collisions. It could be that it's uncontrollable. So I might have something which is fully Dockerized, cloud deployable. It's a microservice. I can stand it up anytime, anywhere. But I can't control the data, I can't control the functional characteristics, and I can't control the performance characteristics as well. And actually the third one, which I realize now is number 2, the third one is what we sometimes refer to as agile bottlenecks, especially within a microservices type of architecture. I might be waiting for functionality to be delivered by another team, but that's not planned for 2 sprints out. So I'm roadblocked right now. I can't move forward on testing the thing that our team are developing, and trying to coordinate those schedules across multiple teams becomes very complicated. So now there are challenges to each of these, or solutions to each of these, should I say, and service virtualization is the enabling technology. Think about service virtualization as basically creating a simulation for your external dependency, like a powerful mock or a stub or a digital twin. These are other terms that people use for this type of technology. So if you're waiting for access to a shared system, well, the chances are you've got access to it at some point. So you could capture the current behavior, capture the interactions with the live systems, and then model those interactions and provision them as simulated digital twins. If I'm talking about an agile robot situation, here what I want to do is to leverage prototyping and model the behavior based on the contract before I actually start implementing the functionality. Yes, that's something that you need to do before you actually jump in there and start coding, but what it's going to do is it's going to help the development team really understand that they are developing the right contract, or they've published the right contract, that it does satisfy their requirements, and a simulation is much, much quicker to put together in some kind of mock framework that can be then shared with other teams so they can get a head start before the functionality is implemented. And then the last, all about that uncontrollable environment. If I've got a prototype, if I've got a simulation, what I can then do is then start synthetically generating additional data, different performance characteristics, and model those safe interactions with the backend systems. This is really one of the keys for unlocking shift left performance testing and unlocking continuous performance testing. Because without the concept of service virtualization, I'm always going to run into the challenges where I'm trying to performance test my system earlier, but the backend system that I have access to can't handle the performance that I want to push through it. So how does this work? Well, as we talked about in the chat, and I saw somebody asking about the kind of a multitude of different types of ecosystem and different types of front ends. This is actually where Parasoft SOAtest excels. We talked about SOAtest today for API testing, but it really works as an orchestration framework, giving me the ability to orchestrate test execution against front end, either through integrations with Appium or directly through native or Selenium-based executions with those headless or non-UI driven interfaces such as the APIs, and correlating that with the backend systems through things like NoSQL or SQL calls. Those tests then become key artifacts that we can leverage for early stage performance testing and security testing. But the problem that we're talking about right now is the problem of the test environment, and that I have all of this stuff on the back end that I'm trying to connect to a variety of different protocols. And I might have Kafka services within my microservices ecosystem. I might have MQTT if I'm talking to a connected thing. I might have industry formats like ISO 20022 for payments or HL7 for healthcare interoperability. How do I get control over that test environment, because I'm running into these challenges that we talked about before? This is, as I said, where service virtualization comes in. So by capturing the behavior or modeling it, I'm able to start injecting additional use cases. I can model corner conditions or use cases that I wouldn't normally get, maybe demonstrating an internal server error or malformed response. I can also use that virtual asset to simulate a security scenario, whether that's an exceptional security use case of maybe an OAuth verification not working, or it might be actually making an external service that I'm accessing return back with some data that could potentially be used for a penetration attack. And it also gives me the ability to start simulating the behavior of a backend system, testing the boundaries of my service level agreements. Now, by taking this and combining these two into together with safe test data, I have a complete test environment that's at my control. This test environment can be leveraged by individuals and being able to use those during your test automation creation or even your manual testing activities as you're verifying specific use cases, changing out and re-provisioning what your test environment looks like. Maybe you want to use a virtual asset that's simulating a negative scenario 1 minute, and then you want to change it to work with a positive test scenario. I can then take that same template and stamp it out as part of my CI/CD process. So upon check-in, I'm going to run through a variety of different testing techniques. But then when it comes to functional test automation or performance testing, I can leverage that template and stamp out different instances for different purposes, and then aggregate all that data together into the centralized reporting and analytics dashboard that we talked about and that I showed you earlier. This combining of all of these pieces together basically makes your test environment fully controllable, but also disposable as well. So by leveraging containerized infrastructure and dynamic provisioning, I can stand up a test environment anytime, anywhere. I can deploy and then destroy. So I can optimize my use of test infrastructure as well as test all of the different boundary conditions. So we touched upon those three key areas, and hopefully you found that useful and interesting for today. We do have time to kind of dig into a few other things as appropriate. What I will do is I'll leave you with a couple of calls to action. So the first is Parasoft Virtualized that we just talked about. There is a community edition version of Parasoft Virtualized, which is free. So basically register your email. You get access to using service virtualization within your local environment. It enables you to simulate HTTP-based assets and protocols and gives you full access to that rich environment that Parasoft Virtualize is, which is very similar to what we saw in Parasoft SOAtest. The last thing is the thing that I started with in today's session. So please do come by the Parasoft virtual booth and register to win an API and IPA tasting session. So there's a brewery based out of Monrovia, which is where we are in Southern California, Hop Secret. And they've got a great set of beers. We've been doing a few events with them recently, and this will be an event for your team, up to 10 people. So please come by the booth, register, and enter to win a beer tasting with your team. So with that being said, I'm actually going to step back to the virtual portal here and see if I can see any of the questions. So please feel free to kind of throw your questions in there. Okay, so let's look and see. Okay, you're using Azure for requirements. So the traceability workflow that I talked about a few moments ago. So let me actually show a slide that articulates that a little further. So there's actually a traceability workflow here where not only am I doing the reporting centrally, but I'm also sending the defect locations. Today, we support a Jira-based TeamForge, version 1, Cobima, and Siemens Polarium product. Azure DevOps is actually coming. It'll be available in the next release that comes out in the September timeframe. So if that's of interest to you, please feel free to reach out to us, let us know. That'll be something that we can follow up on. Okay, so in other words, you've talked about all the things I run into. Yes, automation is fun. It is guaranteed to drive you crazy because you're going to be having to fix it. Hopefully, you've seen today how you can leverage some of the technologies to kind of inject some of those things going. What requirements tools are many people using? I see Joy answered that. Yeah, Jira and X-Ray are two commonly used frameworks that we see. Jira, we're seeing a lot of people use for agile planning. You'll see here in the little logos, there's X-Ray, Qtest, and Zephyr. These are the three which we see the most. X-Ray is actually the one we use at Parasoft for our own internal processes. So, okay, and definitely, code changes, breaking automation, that happens all the time. And that, hopefully you've seen that with Selenic, we can self-heal that UI test automation. Apologize, I'm rolling backwards rather than forwards through them. Okay, so yeah, so I did see this one when I was looking earlier. We have a mix of products, website and mobile. So when it comes to mobile, you're probably going to be wanting to evaluate something like an Appium. Experitest have a great tool for creating those Appium test scripts, and then those Appium test kits can be plugged into your pipeline. One of the key things that we can do with SOAtest, as I mentioned before, is orchestrating the execution of not just that not just that mobile interface, but also the backend systems going to the database, going to the mainframe through MQ, for example, or talking to some enterprise service bus. Okay, we usually wait for performance testing until the end of the program increment because all the code keeps changing sprint over sprint. That is a very common situation. I will say that it is not a good situation to be in. Yes, the code is going to be changing sprint over, check-in over check-in, but what you do want to be doing is considering doing your performance testing in a continuous manner. What we do at Parasoft is we actually do two things. We do run our performance tests every night. They're not practical to run on every check-in, but we do run them every night so that we have feedback the next day, excuse me, as to if we've introduced any performance issues. And there's actually something else that we can do as part of Parasoft Selenic, which I didn't show. So here you'll see that as we're running the Selenium tests, I talked about the healing. There's this thing here that says execution time threshold exceeded. So as part of running the tests, we're actually monitoring the execution time of a particular test scenario versus the average. And then we can set a threshold up that says, okay, what's the threshold between the two? For the purposes of my demonstration, what I do is I actually set that threshold very low. So let's go ahead and, oops, my mouse is not wanting to behave today. If I go to my Selenic configurations, so here I actually set my threshold to 1%, right? So because I want to see those issues. But I might say that, hey, it's a 10% threshold. And what this does is it gives you an early warning for potential performance issues without having to do anything different. Basically you're baselining the execution times of your test automation. So this is something which one of our clients in Canada is doing exactly this thing for the purpose of early capturing potential performance degradations so that they're caught earlier, fixed earlier. So this you can do, in Sprint, actually immediately. You leverage smart test execution, and either the work item-based execution or the test impact analysis. Leverage those to focus down on just the tests that are impacting the code that's been changed, and then you can use this to kind of make sure that you're not introducing any performance issues. That'll help you kind of make sure you're not capturing a performance challenge right at the end of the cycle. Vastness of various tools and frameworks, difficult to choose the best one for you. Yeah, for sure. There are a lot out there. Certainly, even when it comes to web UI automation, I mean, Selenium right now, I would still argue is king, so to speak. But there are other ones out there. There's Cypress, there's Playwright, both increasing in kind of noise and potentially adoption. So I think it's important to evaluate which makes sense for your team and makes sense for your skill sets. Certainly what we've focused on is Java, Selenium, because that's certainly based upon the research that we've done, the majority of people trying. And the biggest challenge with starting is figuring out how to wire together all of the classes. And that's what we've addressed with the creation functionality of Selenic. Okay, developers stack check-ins on top of each other. It never ends. No one wants to use a gated check-ins either. Yeah, I'm actually not a fan of gated check-ins either. We have a lot of tooling around developer tooling to actually help with code quality through the use of deep code analysis for quality, reliability, and security issues, going beyond what you would get with like a SonarQube or an open source technology or Linter. And I've had people time and time again ask me, can we gate the developers so that they can't check in code until it's clean? And my simple answer to that is we could, but we're not going to. We used to have that technology 15 years ago. And in fact, you'll find two things out very quickly. First of all, developer productivity will go down because they'll be actually using that as the reason for non-delivery. Plus, developers are smart, so they'll figure a way around the gate. It's much better to have a proactive approach where you give them the technology in their IDE, and then you have a trust but verify. So you have an automation run that runs as part of your CI/CD process. It's analyzing the whole code base, which is going to give you better coverage because you're analyzing the interdependencies. What I do say is that you want that visibility in the build, and you want to be able to get the quality of the build kind of consistent. Because if you are just letting the debt build up, then you are going to have a problem. So I don't like gating, but I do like the review of the quality in the morning stand-ups. That's the thing that we do at Parasoft. And if there's a broken build or if there's an increase in static analysis violations, which there never is because our team always do it proactively, but test automation breaks, right? So you review that in your stand-up and it's addressed that day. It's not left until the end of the sprint cycle. Okay, and then I'm going to just pick on one more question. Okay, okay, I'm going to pick two and I'm going to weave them together. So I see most of the issues in the execution exactly. I spent a lot of time my days triaging what was done months ago and figuring out what what our biggest problems are. The builds take 3 to 4 hours to run. So the 3 to 4 hours to run, that's where you can use smart test execution to optimize that. Ours, we run 4,500 regression tests against our code base. It takes overnight to run those. So what we do is we use testing impact analysis in the day. So the developer checks in the code, they get immediate feedback, they fix the problem, the nightlies don't have the problem. That's kind of our workflow. And then there's another one here is figuring out what's best to automate and what can be manually tested. Yeah, that's a big one. That's good. That would go on for longer than well, we're actually at time. That would go on for a lot longer to discuss that one, but definitely be happy to kind of have that discussion offline. So thank you everybody for joining. Thank you again for joining the session. Please feel free to come by the booth, ask questions, register for your chance to get some IPAs, and enjoy the rest of the conference. And I think we've got one more keynote that starts at the top of the hour, so looking forward to that. Thank you again, and have a great evening wherever you are.